A city of 1 million people existed without a single electric light. Ancient capitals reached a scale that makes you question what we think we know. How did they keep the water flowing, the food coming in, the streets clean for populations bigger than many cities today? There were 15 hidden engineering systems that made these giant cities possible. It's a complete blueprint for how civilization built its first megacities from nothing. A Roman aqueduct worked on gravity alone. A city built on a lake managed its waste. The solutions they came up with speak directly to our own urban crises now. Sustainability density. There's a forgotten principle in a 2,000-year-old sewer that could fix a problem in you, that traveler walking for days, finally cresting a hill and seeing it. Rome, a living mountain of humanity just stretching out. The walls alone swallowed the landscape, and from miles away you could hear it, that deep, constant hum. 1,000,000 voices, carts, lives. That feeling, that impossibility of scale, that's where this starts. What did it mean for a city to be massive back then? It wasn't about a big wall or a palace. Scale was measured in 3 practical ways, brutal ways. First, population density. Urban centers cramming 200,000–300,000 people into a space you could walk across in a few hours. Second, geographic footprint. These weren't cozy villages. The ceremonial core with its Avenue of the Dead, its pyramids, that covered over 8 square miles, a planned grid on a colossal canvas. And third, economic complexity. A massive city was a vortex, sucking in grain from Egypt, silk from China, timber from Lebanon, and sending finished goods back out across continents. This scale was never an accident. Archaeologists say it was a deliberate act of will, a staggering one, a statement. A capital city was engineered to function at a size that would make a medieval town look like a hamlet. And to get there, planners faced 3 problems, immutable problems. How do you feed a sea of mouths that can't farm? How do you manage the physical waste of that many bodies without poisoning your own water? And how do you move people, soldiers, trade through crowded streets without permanent gridlock? These questions haunted every ancient architect. In Han Dynasty N, officials didn't guess. They conducted censuses, meticulous ones, recording every household, not just for taxes. It was a blueprint. They needed to know exactly how many people lived in each district, to calculate the grain for the state granaries, the number of guards for the gates, the capacity for the aqueducts feeding the public baths. They were running the numbers for a metropolitan organism. So before the aqueduct, before the sewer, you have to sit with that puzzle, that daunting puzzle. If you were given a blank slate of land, told to build a capital for 500,000 people, using only pre-industrial tools, where would you start? Your first decision would define everything. It wouldn't be about monuments. It would be about the one resource no city can survive without. Water. The water had to move on its own. That was the first thing. Before you could build anything, the engineers would walk the land. They had a tool, a long wooden frame with a water groove along the top. They'd set it down and watch the water's surface. They were looking for a line, a very slight downhill slope, from a mountain spring miles away all the way to the city's heart. They were calculating a path for gravity, letting it do the work. The Aqua in Rome, that was a masterpiece, a stone river in the sky. It descended only about a foot for every 300 feet it traveled. That gentle fall is what brought fresh water into the city for centuries. This was the lifeblood. A consistent supply wasn't just for drinking. It was the foundation of public health through the bath complexes. It powered mills to grind grain. It supplied tanneries, dye works, foundries. And it was a display of power. A public fountain in every neighborhood was a daily promise. A statement that order and abundance prevailed. Different civilizations solved it differently. The Romans built their elevated channels, but in Persia they invented the Qanat. Instead of bringing water over obstacles, they tunneled for it. Teams would dig a vertical shaft down to a water table, then dig a gently sloping tunnel backward for miles to bring that water to the surface at a settlement. It was a hidden river, protected from evaporation, a secret artery in the desert. Earlier in Mohenjo-Daro, they built the first known urban sanitation network. Every house had a bathing area and drains. They connected to covered brick sewers under the streets, all leading to the river. This wasn't an afterthought. It was in the original blueprint. The system was never just one channel. It was a complete organism. It began at a protected source. The water flowed through the main channel, often through settling tanks. Sand and silt would drop out there. Then it entered the distribution network. A labyrinth of pipes feeding public fountains, baths, elite homes. Maintenance was constant. Teams inspected, cleared blockages, repaired cracks, and it was governed by strict legal codes, water rights and theft penalties carved into stone. Constantinople took this to an extreme. They built not one, but two massive aqueduct systems. If an enemy or an earthquake damaged one, the other kept the city alive. Engineered redundancy, a 2,000-year-old lesson in avoiding a single point of failure. With all our technology, could your water survive if every electric pump failed tomorrow? The ancient engineers built systems that did, for generations. But bringing that much water into a city created the next crisis. What do you do with it all once it's been used? The clean water that entered a home had to leave, now carrying away the waste. Managing that outflow without poisoning the river you drank from, that became the next great puzzle. The streets of ancient Rome were actually cleaner than the streets of Paris 1,000 years later. That's a fact that makes you stop. A city of 1 million people. Where did it all go? It went under the streets. Under the cobblestones. There was a system there and it worked for over 1,000 years. The Cloaca Maxima, the Great Sewer. It started as a ditch, an open channel for stormwater draining the marsh between the hills. But the engineers saw something more. They covered it. They vaulted it in stone. They expanded it until it became the backbone for the whole city's sanitation. This wasn't just about removing filth. It was a calculated solution. Engineering for livability at a scale that seems impossible. Historians point out it was never one thing. It was a system, a three-part strategy. First, the main sewer trunks like the cloaca. They were built with a precise downward grade. They used gravity, the same principle as the aqueducts, but in reverse. Fresh water from public fountains from the baths was channeled into those tunnels. That constant flow acted as a flush. It scoured the channels. It carried everything toward the Tiber. Second, the public latrines. They were built right over the channels, often elegant spaces, marble seats. They were social hubs, and they were flushed by water diverted from the aqueducts. And third, there was a formal service for collecting organic refuse from homes and markets. That material wasn't just dumped. It was often repurposed, taken outside the city walls for agriculture. An early circular economy where waste became fertilizer for the farms that fed Rome. The engineering was deceptively simple. They used waterproof cement, tightly fitted stone blocks to line the tunnels. The grade was everything. Too steep and the water would rush away, leaving solids behind. Too shallow and everything would stagnate. They found the balance. Maintenance was a public duty, overseen by officials called aediles. Their job was to enforce cleanliness laws, to ensure streets were swept, to keep the sewers clear. A clogged sewer was a civic emergency. This kind of thinking appeared much earlier. In the Indus Valley, cities like Mohenjo-Daro, every house had a dedicated bathing area with a drain. Those drains connected to covered brick sewers under the main streets. They had manholes for access and cleaning. They even designed systems to separate bathwater, which was relatively clean, from other waste, redirecting it for other uses. They were managing water quality and quantity ago. It forces a question. Our modern system is out of sight, out of mind. We flush and forget. But these ancient systems made the process visible, integrated, often cyclical. They treated waste as a logistical challenge to be solved, and sometimes as a resource to be recovered. They engineered a clean city not just for the elite, but as a public health necessity for the entire urban mass. But with a clean city secured, a more urgent imperative loomed. How do you stop 1 million people from going hungry? A ship from Egypt would take 2 months to reach Rome. But the grain inside it, that grain only had to last for 2 minutes. Once it docked at Ostia, it was loaded onto barges, pulled up the Tiber, unloaded, weighed, everything recorded, and rushed into the city's granaries. The whole operation was a single frantic heartbeat, in a system that could never stop. Because in a city of 1 million people, a break in the grain supply meant more than hunger. It meant riots. It meant the collapse of order. This was the third engineering marvel, not a structure you could see. It was a logistical web stretched across the Mediterranean, an empire-wide machine designed to do one thing: keep the capital fed. The system had a name. It started not as charity but as calculated policy. The state purchased vast quantities of grain, mostly from Egypt and North Africa. This wasn't left to chance or the open market. It was a massive state-sponsored logistics network. Economic historians call it the ancient world's largest public service. The grain was then sold to citizens at a fixed, subsidized price, or later distributed for free to eligible male citizens. This was a social contract written in wheat. A full belly meant a stable population. It prevented the kind of desperation that could topple governments. But buying the grain was the easy part. The true engineering challenge was moving it, and then storing it without ruin. The journey was perilous. Ships braved the open sea. Once at Ostia, if the river was too shallow, the cargo was transferred to lighter river barges for the final trip to Rome. Every step was monitored. Scribes recorded the origin, the quantity, the quality. There were officials whose only job was to police against fraud and spoilage. This was a supply chain with accountability built in, before the term was invented. Then came the granaries. These weren't simple barns. They were high-tech storage facilities engineered for preservation. The complex is the perfect example, a massive warehouse district near the Tiber. Its design was brilliant in its simplicity. The floors were raised on pillars or thick layers of mortar. That created an air pocket beneath, a barrier against ground moisture and pests. The walls were double-layered, thick and windowless, providing natural insulation against temperature swings that could cause mold. Ventilation shafts were strategically placed to allow a constant, gentle airflow, keeping the grain cool and dry. These could hold enough grain, olive oil, other essentials to feed a significant portion of the city for months. They were the empire's strategic reserve. The system's strength was its redundancy. Grain came from multiple provinces. It traveled on hundreds of ships, not a single fleet. It was stored in multiple granaries across the city. This distributed network was its own form of resilience. If one source failed, another could be tapped. If one warehouse had a fire, others held reserves. But this map of abundance was also a map of fragility. Every line on it, every sea route and road, was a potential point of failure. A storm could sink a fleet. A rebellion in Egypt could cut the lifeline. The entire apparatus depended on imperial control, on peace, on the relentless rhythm of the seasons and the seas. The people of Rome lived, quite literally, at the end of the world's longest, most delicate thread. And yet this reliable food supply did more than prevent famine. It enabled something profound. It freed a huge portion of the population from farming. They could become soldiers, administrators, artisans, merchants, philosophers. The grain dole was the foundation upon which Rome built its complex economic and cultural engine. It turned a city of consumers into a factory for civilization itself. But feeding and cleaning, a giant city created a new kind of energy within its walls, a human energy. And that energy created a problem of a different sort. How do you move 1 million people through streets never designed for carts, for crowds, for the daily crush of existence? The answer lies not in widening roads, but in mastering time. All roads led to Rome. That was a literal fact. For an empire of that size, movement wasn't about convenience, it was survival. The grain from Egypt, the marble, the legions from the frontiers, all of it had to reach the capital. And it had to get there without chaos. So they built a network of roads, a layout of streets so deliberate, it still shapes how we think about cities. A Roman road was built in layers. They'd start with a deep trench, pack the earth down firm. The first layer was the large stones for a foundation, then a thick mix of rubble and lime. Next, the nucleus, a finer concrete of gravel and sand, and the surface, the dorsum, was made of interlocking stones, fitted so tightly a knife blade couldn't slip between. The road was cambered, curving up in the center with ditches on either side, so water would run off. This kept the foundation from rotting. It was built to last centuries, to bear the weight of armies, endless caravans, a permanent artery stamped onto the land. But the genius was in the system. Milestones marked every 1,000 paces. They told you the distance to the next town and to Rome itself. Called mansions were placed a day's journey apart. They offered rest, fresh horses, repairs. That turned a cross-continent journey into a series of manageable legs, a logistical clockwork. It let information, troops, goods move at speeds the ancient world had never seen. Inside the city, the same principles applied, just compressed. Military planners knew wide, straight streets served three functions. First, they allowed rapid deployment of soldiers to quell unrest or defend the walls. Second, they enabled commerce to flow, carts bringing goods from the river ports to the markets. And third, those streets aided sanitation. The gentle slope and open design let rainwater cleanse the surfaces, channeling waste toward the sewers underneath. You see this intentional design in cities built from scratch. In what's now Mexico, built on a rigid grid centered on the Avenue of the Dead, that central axis wasn't just a street, it was a ceremonial spine, aligning the major temples and pyramids. It directed the movement of people towards centers of power and ritual. In Babylon, the processional way was a broad, paved corridor, lined with glazed brick images of lions, engineered for spectacle, to channel vast crowds during festivals, to display the king's majesty. The pavement itself was part of the message. Roman cities often followed a template. Two main streets crossed at the center. The Cardo ran north-south, the east-west. Where they met was the Forum, the public heart. From these main arteries, a hierarchy of smaller streets branched out, then narrowed into residential alleyways. Gates were placed at the ends of the main roads, controlling entry and exit. This wasn't just orderly. It was a form of social and military control baked into the brick and stone. So think about traffic in your own city. The stoplights, the highways, the congestion. Now picture an ancient capital. No traffic signals, no asphalt. Yet the flow was engineered through geometry, through hierarchy, through the foresight of placing a wide street where the most people needed to go. The chaos of a million lives was given a channel, a pattern, architecture as a directive for motion. But these channels did more than connect points A and B, they created empty spaces in between. And in those spaces, the ancient engineers performed their most subtle magic. They designed not for movement, but for pause, not for efficiency, but for gathering. The true test of a megacity wasn't whether people could move through it. It was whether they could live together within it. The open plaza was the city's living room. After the roads were built, after the grain was stored and the water flowed, the planners had this delicate task. They had to give that huge population a place to just be, together, not as a mob but as a community. That was the fifth engineering marvel, the deliberate design of civic space. The Roman Forum wasn't just a pretty square. It was a carefully scripted stage, a stage for the drama of public life. The great plaza of did the same thing. These were open-air engines. Engines for political and social cohesion, built at a scale to match the city itself. Every element in these spaces was placed with intention. The temple was always visible, a constant reminder of divine favor and earthly power. The law courts, the basilicas, were right next to the main square, so justice was seen to be done. The market stalls lined the edges. That brought economic life into the heart of civic affairs, and the public baths were often nearby. Not just for cleanliness, but as social hubs, places where news was exchanged and deals were struck. This clustering wasn't accidental. It was a form of soft control. By concentrating the essential functions, worship, law, commerce, socialization, in one magnificent district, the planners kept the populace engaged. They kept them monitored, and ultimately loyal to the system. Monumental architecture served a dual role, utility and propaganda woven together. A soaring column wasn't just support for a roof, it was a statement of permanence and strength. A grand staircase leading to a temple wasn't just access, it was a ritual pathway. It elevated the experience of approach. The materials themselves told a story. The Romans perfected brick-faced concrete. It was cheap, it was strong, and it could be poured by semi-skilled laborers into wooden molds. That allowed for rapid, large-scale construction. Vaults and domes that defined their civic buildings. They used standard modules, pre-cut stones, uniform bricks, so teams could work simultaneously on different sections of a massive project. It was ancient prefabrication. Then consider a basilica began as a Roman hall for law and commerce. Its design was brilliantly simple, a long, rectangular space. A high central nave with lower side aisles, often ending in a semicircular apse where the judge would sit. That layout provided clear lines of sight. It could accommodate hundreds. But that same open, flexible floor plan made it a perfect covered market on rainy days, or a meeting hall for citizens. When Christianity later adopted the form for its churches, it was borrowing a blueprint for gathering people that Rome had already engineered to perfection. Then there were the Thermae, The vast imperial bath complexes. They were marvels of social engineering, more than just places to get. They were day-long destinations. You would move through a sequence of rooms, the cold, the warm, the hot, each with its own social rhythm. There were libraries attached, lecture halls, gardens, gymnasiums. For the price of a very small coin, any citizen could spend an entire day in opulent surroundings, rubbing shoulders with all levels of society. It was a powerful tool, a tool for fostering a shared Roman identity, a tangible experience of the empire's prosperity. The engineering of crowd management reached its peak in the amphitheater. Take the Colosseum. Its oval shape provided excellence from every seat. The vast awning, the Valerium, was manned by a special detachment of sailors. It shielded spectators from the sun. But the real genius was underneath. A labyrinth of passages, ramps, and lifts, the Hypogeum. It allowed gladiators, animals, and stage sets to appear magically in the arena above. The seating was strictly stratified by social class. That reinforced the social order even during leisure, and the acoustics were carefully considered. The shape of the bowl and the materials used helped carry sound from the arena floor to the highest tiers, ensuring everyone heard the drama unfold. A perfect case study is Trajan's Market in Rome, often called the world's oldest shopping mall. Built into the side of a hill, it was a multi-story complex, over 150 shops and offices. Its semicircular form followed the curve of the forum below. It had a covered market hall with a soaring vaulted ceiling for perishable goods, and tiers of shop units facing onto an internal street. There were even apartments on the upper floors. This was a single integrated structure. It managed retail, administration, and residential space. It handled the daily commercial needs of a vast neighborhood. It turned commerce into convenient, organized architecture. So look at your own community. What public space serves as its multifunctional heart? Is it a library that also hosts classes and community meetings? A main street with cafes, shops, and a town square? That idea of a design space that draws people together for multiple purposes is a direct inheritance. An inheritance from these ancient planners. They understood that a city of 1 million souls needed more than infrastructure to survive. It needed places to feel like a community. To witness power, to participate in society. But building these monumental plazas, these soaring temples and vast markets required something colossal behind the scenes. It demanded a hidden network, a network of extraction and labor that stretched to the very edges of the known world. The stones for the forum did not quarry. The stones for the forum had to come from somewhere. They were from hundreds of miles away. A granite column for the Pantheon started at Mons in the Egyptian desert. That stone was a mountain. Workers would cut trenches around it, drive in wooden wedges, then soak the wedges. The wood swells, the pressure builds, and with a crack the block splits free from the bedrock. That was just the start. The real problem was moving it. A 50-ton column in the middle of a desert. How do you move that? The answer was a mix of brute force and simple physics. They'd lever it onto a huge wooden sledge, pour a slurry of water and mud on the path ahead. Then teams of oxen or hundreds of men with ropes would pull the sledge over this slick track. The friction drops, and it begins a slow, grinding procession toward the Nile. That was the hidden network, an empire-wide supply chain for stone, for timber, for metal, the lifeline. At the river, the stone is loaded onto a special barge. These barges were their own kind of engineering, built for unbalanced, immense loads. To transport an obelisk, they'd calculate the buoyancy. Position the stone so its weight was perfectly centered. One mistake and the barge capsizes. The monument is lost at the bottom of the Nile. The journey to the Mediterranean, then across the sea to Ostia, could take months, a calculated risk repeated over and over. Because Rome's appetite for grandeur was endless, on site the assembly begins. And here standardization was everything. Roman bricks were uniform. They came from big brickyards stamped with a mark for quality. These identical modules meant any labor crew anywhere could build a wall fast. They didn't have to custom fit each stone. They followed a pattern. That modular thinking was everywhere. Pre-cut column drums, standardized roof tiles. It was ancient mass production. It enabled speed. It enabled scale. But the revolutionary material was Roman concrete. Opus, it looks plain. A mix of rubble, lime, and a special ingredient, volcanic ash from. This ash, mixed with lime and water, creates a chemical reaction. A reaction that produces a cement that can cure underwater and get stronger over centuries. This concrete could be poured into wooden molds. It could form curves, vaults, domes, things stone block construction could never do. It freed architecture from the post and lintel. It created the vast space inside the Pantheon's dome, and it used local materials, rubble from old buildings, volcanic sand. So you didn't have to transport every building block from afar. It was fast, it was strong, it was relatively cheap, the enabling technology for an urban building boom. Behind all of it was the organization of labor. This wasn't a haphazard crowd, it was a stratified machine. At the top, the architects and engineers, men who understood geometry, stress, hydraulics. Then the skilled artisans, master stonemasons, the carpenters who built the complex scaffolding and cranes. Metalworkers forging tools and clamps, and beneath them the vast workforce, thousands of laborers. Many were paid, skilled freemen, but a significant part for the most brutal work came from the enslaved, or were provided as tribute from conquered provinces. This mobilization of human energy on a colossal scale was a state project made possible by imperial wealth, by the political will to command such resources. They used simple machines with profound effect: the winch, the capstan, the block and tackle, a crane powered by a giant treadmill, a wheel where men walked inside like hamsters to provide the lifting force, ramps of earth and timber spiraling up the side of a rising structure, letting workers drag stones higher and higher. You can see the ghost of this process in the tool marks, in the leftover ramp foundations, in the precise sockets cut for lifting levers. So the question is, could we build a Colosseum today without diesel cranes, without steel, without fossil fuels? The ancient engineers did. They built it with levers, ropes, ramps, and the coordinated effort of thousands of trained hands. They built monuments meant to last, and many of them have. That scale of construction, though, it created a towering symbol, a symbol of wealth and power that demanded protection. For every stone laid, a city made itself a target. The final engineering challenge wasn't about sustaining life within the walls. It was about preventing death from outside them. Constantinople's walls were a declaration. They said this city would not be taken, and for 1,000 years they weren't. Through sieges, earthquakes, the whole slow collapse of empire. That was the sixth marvel, defensive engineering. A capital city with all its wealth, its people, that's the ultimate target. To last, it had to become a fortress, but a fortress at the scale of a metropolis. Its security came first. Before the markets, the libraries, the theaters. Without it, the other 5 systems. They wouldn't have mattered. The walls are the classic case, 5th century. They weren't a single line, they were a system layered. First, a low outer wall, then a wide moat deep enough to flood, then the main inner wall 40 feet high in places, 16 feet thick. Nearly 100 towers, each spaced so their fields of fire overlapped. The space between the walls was a killing ground. Anyone who got past the first barrier was trapped there, exposed to arrows, stones, Greek fire from above. That's defense in depth. A concept military historians still look at. The stone's thickness wasn't random. It was calculated. To withstand the heaviest siege engines of the time, the height was calculated to make scaling ladders useless. The tower placement was geometry for war. Each one gave a clear line of sight to the base of the next tower, no blind spots. The walls alone weren't enough. The real art was in using the landscape. Constantinople was on a peninsula. Its harbor, the Golden Horn, was protected by a massive chain. Floated on logs, it could be drawn across the entrance to block ships. The sea walls were less imposing but still strong. The land walls followed the crest of hills, forcing attackers to fight uphill. Engineers used rivers as moats, steep cliffs as natural barriers. They turned the geography itself into a weapon. Inside the city, security took another form, managing hundreds of thousands of people during a crisis. Guard posts at major intersections at the gates, watchmen patrolling after dark. Many cities had curfews. Gates shut at sunset, opened at dawn, controlled by trusted regiments. This internal control was vital. It prevented panic. It stopped spies. It kept order when the outside was trying to break in. The city had to be secure from within as much as from without. There's a powerful case in ancient Beijing from the Ming Dynasty. It wasn't just a walled city. It was a series of walled cities, nested inside each other like boxes. The outermost walls enclosed the whole metropolitan area. Inside that, the imperial city wall. Inside that, the forbidden city's own fortifications. Each layer had its own gates, its own guards, its own independent defenses. An attacker would have to breach not one, but 3 separate circuits. This design protected the symbolic heart of power, and it let the outer districts act as a buffer, urban security as a concentric diagram. So you have to ask, our modern cities prize openness, connection, glass and transparency. How do you balance that desire for access with the ancient, hard-learned need for security? We don't build walls like that anymore. But the principle remains, designing resilience into the fabric of a place, creating layers of safety, whether they're physical barriers, surveillance networks, community trust. Constantinople's walls allowed a unique economic system to flourish behind them, a system of incredible complexity because the basic fear of invasion was gone. Traders could make long-term investments, banks could operate, scholars could debate. The security of stone unleashed the energy of the mind, and that energy created the final engineering marvel, the most abstract one. The seventh marvel was invisible. It wasn't stone, it wasn't water, it was information. A capital city that size couldn't run on muscle. It ran on data, on lists, on ledgers, the precise knot in a cord, the careful mark on a clay tablet. This was the soft engineering of bureaucracy, a system of rules and records, communication. It turned chaos into something you could manage. It was the operating system for the whole urban machine. In Mesopotamia, the first accountants appeared. Not in banks, in temples. They needed to track the grain coming in, the livestock, the wool. Their solution was the cuneiform tablet, a damp clay surface. You inscribe it with a stylus, a permanent record, a transaction, a tax, a law. These tablets filled entire archives. They were the hard drives of the ancient world, storing the data that told the city who owed what, who had been paid, what was in the granaries. Without that, the food distribution we talked about earlier, it would have been impossible. It was all based on records. The Inca took a different approach, a brilliant one. They used the quipu, a collection of colored knotted cords. The type of knot mattered, its position on the string, the color of the cord itself. Each element held specific meaning. A quipu could record census data, tribute obligations, even narrative histories. They had specialized record keepers. The trained to read and create these devices. It was a three-dimensional database, tactile, engineered for a society without a written alphabet. Yet it could manage an empire, thousands of miles of mountain terrain. This data collection had one purpose: informed resource distribution. Economic anthropologists point this out. Ancient states didn't guess, they counted. A Roman census, it wasn't just about knowing the population. It was about predicting the need for grain, for water, for military recruits. A Han Dynasty land survey, it meticulously mapped fields by quality and yield. That data determined tax rates. It told the central government which provinces had a surplus, which were in deficit. Allowing for strategic transfers of grain to prevent famine, administration was a giant balancing act, and data was the scale. To make the data actionable, you needed standardization. Across a vast empire, a bushel of wheat in one province had to mean the same as a bushel in another. So governments imposed standard weights and measures, official stone weights, bronze volume measures. These were distributed, carefully guarded. Then came standardized currency. The Lydians of Anatolia are credited with the first coins, but it was empires like Rome and Persia that turned coinage into an engine, economic integration. A Roman denarius was accepted from Britain to Syria. It reduced the friction of trade. A merchant no longer had to barter. He could use a universally trusted token of value. This financial engineering created a common economic language across continents. Executing the states will require a structure, a hierarchical administrative structure. Think of it as a pyramid. At the top, the emperor or a central council. Below them, provincial governors, often military commanders responsible for large regions. Then a layer of district officials, tax collectors, judges. And at the very bottom, the local magistrates, village heads, the ones who interacted directly with the people. This chain of command allowed a decision made in the capital to, eventually, affect a farmer. In a distant province, it was a human network, a nervous system for the empire. But a nervous system needs to transmit signals, quickly. That's where the engineering of communication comes in. The most famous example is the Persian Royal Road, stretching over 1,600 miles, from Susa to Sardis. Couriers on horseback would ride in relays, stopping to swap their tired mount for a fresh one. Herodotus wrote it. Neither snow nor rain nor heat nor gloom of night stays these couriers from the swift completion of their appointed rounds. A message could cross the empire in a week, an incredible speed for the time. This wasn't for casual mail. It was for royal decrees, military intelligence, administrative reports. It kept the center connected to the periphery. Other systems were even faster. Simpler though, signal fires, beacon chains. They could relay a prearranged message, news of an invasion, for example, across hundreds of miles in a single night. The Great Wall of China incorporated such beacon towers, an early warning system built into the architecture of defense. So is data the modern equivalent of the ancient scribe's tablet? Absolutely. Today, a city manages traffic with sensors. It allocates electricity with smart grids. It plans services with demographic databases. We've exchanged clay and cord for servers and code. The principle is identical. To govern complexity, you must first measure it. To distribute fairly, you must first record accurately. The ancient administrators were the first data scientists. Their soft engineering, the law code, the tax roll, the courier network, that's what made the hard engineering meaningful. The aqueducts, the walls, it was the mind directing the muscle. Yet for all this brilliant organization, these cities faced a paradox. The very systems that made them magnificent also made them fragile. A single point of failure in that intricate web could unravel everything. The stone was a key. But first it was a poster, a slab of black granite carved in 3 scripts, hieroglyphs for the priests, Demotic for the administrators, Greek for the ruling class. It was a royal decree, a tax break announcement. Engineered to be read by everyone who mattered in Ptolemaic Egypt. That was the ancient world's public address system. In a city of hundreds of thousands, where few could read, the state communicated through monuments, through symbols carved in stone. This was the engineering of ideology, a way to broadcast a single message across a vast and diverse population. Point to the strategy, placement was everything. A law code wasn't hidden in a library. It was erected in the city's main square. Hammurabi's stele, over 7 feet tall, showed the king receiving authority from the sun god Shamash. And below that divine image were columns of cuneiform text, 282 laws, covering property disputes, family matters. It was public, it was permanent. It proclaimed a revolutionary idea, that justice was not arbitrary. That the rules were the same for all, written in stone for all to see. It engineered social order through transparency, or at least the appearance of it. The materials were chosen for endurance. Not clay, not wood, but stone and bronze. Metals that could be cast and mounted high on columns. Stones that could withstand centuries of weather. The message had to outlive the messenger. A triumphal arch like the Arch of Titus in Rome wasn't just a gateway, it was a permanent newsreel. Carved reliefs showed the spoils from Jerusalem, the victory parade. Every citizen who passed under it was reminded of imperial power and military success. It turned a military campaign into a civic landmark. Coinage was mass media in your pocket, stamped with the emperor's profile, his titles, symbols of victory or prosperity. Every transaction reinforced a simple idea. This is who rules. This is what the state values. A Roman coin circulating in Gaul or Britain was a tiny, mobile ambassador. It engineered economic unity and political loyalty with every trade. The content was meticulously crafted. Royal decrees often began with a lengthy preamble, listing the king's titles, his divine endorsements, his benevolent deeds. This wasn't vanity. It was establishing legitimacy. It framed the actual command, a new tax, a building project, as the act of a rightful and powerful ruler. The language was formal, repetitive, designed to sound eternal and unchanging. And they spoke in multiple tongues. Like the stone, the inscription in Persia told the same story of royal triumph in 3 languages: Old Persian, Elamite, and Babylonian. It was carved on a sheer cliff face along a major road, impossible to miss, impossible to remove. It addressed the empire's diverse subjects directly. A monumental billboard saying the king's law is universal, no matter what language you speak. So look around your own city. The words carved on a courthouse facade, the names on a war memorial, the slogans on government building, the iconography on its currency. These are not decorations, they are engineered messages, designed to foster a shared identity, to promote civic values, to reinforce a particular story about order, history, and belonging. We still use public space to tell us who we are and what rules we live by. This symbolic order, this network of stone and bronze messages, had a very practical goal: to make the colossal city feel cohesive, to convince the farmer from the countryside and the merchant from across the sea that they were part of the same system. And that system had to provide for one of the most basic human needs, not just symbolically but physically: a place to live. The Insula was a city inside the city, a vertical island. In Rome, that's what they called it, an island. Dozens of families stacked floor upon floor. This was the eighth marvel, housing on a massive scale. How do you fit 100,000 people on a few hundred acres? You build up. But building up then came with terrifying risks. The solutions and the failures tell a story of density that feels familiar. A typical insula was brick and concrete, shops at street level. The ground floor might be decent. Higher floors were cheaper, darker. The top under the roof was the worst. These buildings could go 5, 6, 7 stories. Ancient writers complained about the noise, the smells, the constant fear of collapse. Fire was the nightmare. So many families cooking over open flames, using oil lamps. A single spark could become an inferno in minutes. No fire escapes, just a single narrow staircase. The Great Fire under Nero, it likely spread through these packed wooden tenements. Archaeologists study the remains. They find evidence of patching, shoddy additions. Landlords wanted maximum rent. They'd add extra floors illegally beyond what the foundations could bear. Walls, sometimes just rubble between thin brick facades, could buckle. This was the unregulated free market of ancient urban living, a perilous game. But the state did intervene. Augustus saw the chaos and danger. He passed the first known building codes in the West. He limited heights to about 70 Roman feet, 6 or 7 stories. He mandated wider streets as fire breaks. He required more fire-resistant materials, brick and concrete, instead of just wood. These were early safety regulations, an acknowledgement that the free-for-all of vertical growth needed rules. For the wealthiest, housing was a different world. A single-family home was built inward. Rooms faced a central courtyard, the atrium. It had its own well, its own kitchen, a private world. Privacy, security, control, but it was a luxury. Only a tiny fraction could afford it. For most, housing was about proximity. Neighborhoods called were microcosms. They had a local administrator, a shared well or fountain, a communal bakery where you brought your dough to be baked, a small shrine at a crossroads for the protective spirits of the place. These were the amenities of high-density living. They weren't private but public. They forced interaction. They created a web of local relationships. Your life was intertwined with your neighbors. A contrast is found in Egypt. At El Medina, a village for the artisans who worked on the royal tombs. This was state-planned worker housing. The village was a neat grid. The houses, while small, were uniform, well built of. Each had a main room, a smaller room, a cellar, a rooftop kitchen. The state provided tools, food, water. There was a community well, a shared temple. This was density with intention, designed for a valued workforce. It shows that when the state had a direct interest in the well-being of its residents, it could engineer a functional, even humane, environment. So look at a modern high-rise. The concrete frame, the elevators, the fire sprinklers, the central heating. These are our technological answers to the ancient problems of collapse and fire. But the social questions remain similar. How do you foster community in a tower of strangers? Where are the shared spaces? Is the ground floor just a lobby, or does it have a cafe, a grocer, a place where people meet? The ancient insula often failed at safety, but it succeeded by necessity in creating neighborhood bonds. People lived in close quarters. They knew each other's business. They relied on each other. Our modern solutions have mitigated the physical dangers, but have we engineered out the social fabric? The challenge for the ancient planner was to pack people in without sparking constant unrest. That vibrant, volatile social fabric was the engine of the city's culture, its economy, its soul. But it was also its greatest vulnerability. And to manage that vulnerability, to keep the peace among the crowded masses, the engineers of the ancient world developed one final overarching system. A system not of stone or water, but of belief. The Colosseum could empty in minutes. They had these vomitoria, which weren't about indulgence, they were passages, wide, vaulted tunnels. They channeled the crowd. Tens of thousands could leave their seats and spill into the Roman streets just like that. That was the ninth engineering marvel, social control through crowd management. In a city of 1 million, the biggest threat wasn't an army. It was the crowd itself, bored or hungry or angry. It could become chaos. So the planners designed the city to manage that energy, to channel it, to release it safely. Public spaces were engineered for movement, for visibility. The tiered seating of a Greek theater funneled every gaze toward the stage. The long U-shaped track of a Roman circus, like the circus, kept the chariot race in view for 250,000 people. The key was unrestricted flow, wide entrances and exits, radial aisles dividing the seating blocks, clear lines of sight to the central event. That design prevented bottlenecks, the kind that could spark panic. It made the experience orderly. Predictable, it turned a potential mob into an audience, and these spectacles weren't just entertainment. They were tools of social control. The gladiatorial games, the chariot races, the massive public feasts, they provided a shared emotional outlet, a catharsis. They directed popular passion into a scheduled, state-sanctioned arena. The distribution of free grain worked the same way. It scheduled the populace. It created lines and routines. It tied survival to the orderly functioning of the state. A hungry crowd is unpredictable. A fed crowd, entertained on a regular schedule, is easier to govern. And the urban design itself facilitated surveillance. Those narrow, winding residential streets in ancient cities weren't just organic growth. They were defensible, easy to barricade from either end, easy for a small patrol to monitor. The broader main arteries allowed for the rapid deployment of soldiers. The forum was an open bowl, a panopticon, where the activities of citizens were on display to authority. Windows from administrative buildings overlooked the squares. This architecture of visibility meant that while the crowd could see the spectacle, the state could always see the crowd. And this control was decentralized. Into the very neighborhoods, Rome was divided into wards. Each had a local magistrate, often a wealthy benefactor, responsible for keeping order, reporting strangers, organizing local festivals, ensuring the neighborhood's quota for public works was met. This system made every community leader an extension of the state's authority. It created a chain of accountability from the emperor down to the head of a city block. Your local leader was responsible for your conduct. It embedded social management into the daily fabric of life. In this was the festival in Athens, the city's most important religious and civic event. The entire population participated. The planning was a logistical symphony. A grand procession wound from the city gates through the Agora up to the Acropolis. It carried a new woven robe for the statue of Athena. The route was cleared and decorated. Stations were set up for officials. The timing was precise, choreographed to include sacrifices, musical contests, athletic games. This wasn't a spontaneous parade. It was a scheduled absorption of the entire city's energy into a single, unifying ritual. It reinforced civic identity, religious piety, political hierarchy all at once. It managed the crowd by giving it a sacred script to follow. So you consider a modern concert, the timed entry tickets, the clearly marked sections and aisles, the emergency exits that double as efficient outflow routes, the security personnel at key or a political protest, the negotiated parade route. Designated assembly areas, the barriers that guide movement. We still use these principles. We engineer spaces and schedules to safely contain and direct collective human energy. The core challenge is unchanged. How do you allow for mass gathering without inviting mass chaos? Managing the daily movement and mood of that many people was a monumental achievement, but it all rested on a more fundamental kind of engineering. The engineering of the human body itself at the scale of a metropolis. Keeping 1 million people healthy was the ultimate test of urban survival. A doctor in Rome wouldn't have known about bacteria, but they understood cleanliness. The military hospitals, they were models of order, separate wards for different ailments, a dedicated staff. They boiled surgical instruments, not because of germs, but because experience showed it led to better recovery. That was the 10th marvel, public health infrastructure. In a city of 1 million, illness wasn't just a private tragedy, it was a civic emergency. So they built systems to manage it with the tools they had. Their framework was the theory of miasma. The idea that disease came from bad air, from rotting matter. It wasn't correct, but it was functional. It led to certain decisions. Cemeteries went outside the city walls. Garbage dumps, tanneries, anything with a foul smell was placed downstream, away from where people lived. Major roads were aligned to catch the prevailing winds to ventilate the city. They were engineering against a perceived threat, and in doing that, they often solved the real one. By removing waste, by getting decomposing material out of the urban core, they accidentally reduced the vectors for actual disease. Then there were the public baths, the thermae, central to the Roman idea of health. They believed in the curative power of water, of heat and cold. The ritual progression, that wasn't just for relaxation. It was a form of hydrotherapy. It promoted circulation, it cleaned the skin. The shared water could spread some things, sure, but the overall emphasis on bodily cleanliness, on the regular washing of hundreds of thousands of people, that had a net positive effect. The aqueducts made that culture possible. A constant flow of clean water wasn't just for drinking. It was for washing away the grime of dense urban life. Healing was also cultivated, literally. Many temples, especially for Asclepius, the god of medicine, had extensive herbal gardens. Priests and attendants would grow plants, study their medicinal properties. Willow bark for pain, poppy for sleep, mint for digestion. These temple complexes often functioned as the first hospitals. The sick would come, make offerings, sleep in a special hall called the. They believed the god would visit in a dream and prescribe a cure. The priests would interpret the dream, then administer treatments from their herbal stock. It was a fusion of faith and pharmacology built into the landscape. The state employed public physicians, too. In some Greek city-states, a doctor was a civic appointment. His salary came from public funds so he could treat the poor. In Rome, notable physicians attached themselves to wealthy households or to the military. The army's medical corps was highly advanced. Field surgeons developed techniques for treating wounds, setting bones, even rudimentary surgeries. That knowledge, born from the necessity of war, eventually filtered into civilian practice. When pandemics struck, they used a brutal logic. There are records from as early as the plague in Athens of officials ordering the burning of corpses and the belongings of the afflicted. In some port cities, like later in the Venetian Empire, the concept of quarantine was born. Ships from plague-stricken regions had to anchor offshore for 40 days before anyone could come ashore. It was isolation by observation, a desperate engineering of time and space against an invisible enemy. So in an age without germ theory, what promoted health? The placement of cemeteries downwind, the constant flush of aqueduct water through latrines and baths, the cultivation of healing herbs in temple gardens, the strategic isolation of the sick. They were working from a flawed map. But their engineering often led them to the right destination. They understood the health of the individual was linked to the health of the city, that public well-being required public infrastructure, and that sometimes the line between a sacred spring and a sterile wound wash was just a matter of ritual. This whole web of care, from the herbalist's garden to the surgeon's tent, represented a city trying to protect its human capital. But a city is more than the sum of its bodies. It's a collective mind, a repository of knowledge, and safeguarding that knowledge, making sure it could survive fire, war, and time that demanded a final layer of engineering. One built not with stone but with words. Beijing's street grid was a kind of prayer. That north-south axis, it wasn't just for moving traffic, it was an alignment. A line drawn from the emperor's throne in the Forbidden City straight through to the Temple of Heaven in the south. This wasn't urban planning, it was cosmology set in stone. The city was engineered as a mirror of the heavens, a sacred machine to maintain harmony between the human world and the celestial order. That's the hidden layer, the spiritual blueprint that directed where every wall went, every gate, every major building. Ancient capitals, they weren't just built for people, they were built for gods. Archaeologists of religion point to a universal principle, the axis, the center of the world. In almost every ancient cosmology, the capital city was designed to be that center, the point where heaven and earth met. Take the Great Pyramid of Giza. It's not just a tomb. Its sides are aligned with near-perfect precision to the 4 cardinal directions. The ancient builders, they didn't have magnetic compasses, they used the stars. They observed the circumpolar rotation, the rising and setting of Sirius. The pyramid's placement, its angle, it was a frozen piece of astronomy, a machine to channel celestial power for the pharaoh's journey to the afterlife. The pyramid was the axis. The city around it, the supporting landscape for a divine project. This thinking, it shaped entire urban forms. The city of the gods, its central avenue, the Avenue of the Dead, is aligned 15.5 degrees east of true north. Why? Researchers believe it was oriented to the setting point of the Pleiades, a hugely important star cluster in cosmology. The Pyramid of the Sun and the Pyramid of the Moon, they anchor this celestial roadway. Walking down that avenue was a ritual reenactment of a cosmic journey. The city's layout was a map of belief. Back in China, the Temple of Heaven complex in Beijing is in sacred geometry. The circular altar of heaven is built with tiers of marble stones. In multiples of the number 9, the imperial heavenly number. The surrounding walls are square, symbolizing the earth. Circle heaven, square earth. The entire design is a mandala, a physical representation of the belief that the emperor, the son of heaven, performed rituals there to ensure good harvests, to ensure cosmic balance for the entire realm. The city's rigid grid extended that order outward, making the whole metropolis a participant in the ritual. This goes beyond symbolism into practical engineering. Processional routes were the city's ritual arteries. In ancient Egypt, the path from the Nile Temple to the desert necropolis was a carefully surveyed line, used once a year during the festival of the valley to carry the statue of the god Amun to visit the royal tombs. The road had to be dead straight, perfectly level. It was a highway for a deity. Its construction required the same surveying skill as a major aqueduct. Faith dictated the engineering specification. Perhaps the most literal example is Angkor, the great capital of the Khmer Empire. It's designed as a stone model of Hindu-Buddhist cosmology. The city is a perfect square, surrounded by a massive moat representing the cosmic ocean. At its exact center stands the temple with its giant serene faces looking outward. The city's gates align with the cardinal directions. The main temples, like Angkor Wat, are built as representations of Mount, the mythical home of the gods. The moats, walls, towers, a scaled-down universe. To live in Angkor was to inhabit a divine diagram. Sacred geometry influenced everything down to land division. The Roman ritual of founding a city, the sulcus, a priest would plow a sacred furrow to mark the city boundary. The resulting square or rectangle became the template for everything that followed. Property lines, street grids, even the proportions of temples, often based on ratios considered divinely harmonious like the golden ratio. This wasn't just aesthetics. It was believed these proportions pleased the gods. They brought stability. Faith mobilized the labor too. Building a pyramid or a massive temple wasn't just a construction job. It was an act of piety, a ticket to spiritual merit. That provided a powerful, non-coercive motivator for thousands of workers, who might donate their labor during the agricultural off-season as part of their religious duty. The project was a collective prayer. So what deeply held beliefs shaped the layout of our modern cities, even if unconsciously. We don't align skyscrapers with star clusters. But think of the wide, ceremonial mall in Washington, D.C. leading from the Lincoln Memorial to the Capitol building. It's a secular processional route, engineered for political spectacle. The zoning laws that separate industry from homes, they reflect a belief in order, safety, a certain ideal of domestic life. Our financial districts with their towering temples of commerce are laid out for efficiency and profit, a modern cosmology of its own. We still engineer our environments to manifest our deepest values. We just call it urban planning. The sound in the Agora was a particular noise. 100 languages, a dozen different coins, the haggling over silk and grain and spice. It wasn't just a market. It was a kind of engineered chaos. The 11th marvel was that marketplace. A city with 1 million people couldn't just feed itself. It had to enrich itself. So it built these commercial hubs, designed to move staggering volumes of goods, to collect taxes efficiently, to turn raw materials into wealth. These spaces were the economic heart, and they were engineered with precision, like an aqueduct. Every major capital had one, a designated commercial core. In Athens, the Agora; in Rome, the Forum and its specialized markets; in Baghdad, the Grand Bazaar. These weren't open fields where traders just gathered. They were planned districts, with key elements working together. First, the open square, often paved, with clear zones, livestock in one sector, pottery in another, textiles under covered porticos. Second, port facilities, warehouses called right on the docks, so you could unload a ship and secure its cargo in minutes. Third, customs houses, tax offices at every major gate, to assess the value of goods before they even entered the city's flow. The whole system was built for throughput, for control. To manage the frenzy, administrations imposed order. They standardized market days, certain days for grain, others for livestock, others for luxury imports. This created predictable rhythms. It let farmers plan their journeys. It let city dwellers know when to buy. They enforced standard weights and measures, official bronze weights, stone volume measures. Market officials would patrol, checking scales for fraud. This reduced conflict. It built trust between strangers. Merchant law developed too, special courts, to adjudicate disputes between traders quickly, so a deal gone bad didn't stall the entire machine. The goal was to reduce friction, to make exchange smooth and fast. The supporting infrastructure was ingenious. Secure storage was paramount. Those massive warehouses near the Tiber in Rome had raised floors against damp, thick walls against theft, meticulous inventory records. Within the market square you'd find money changers' tables, a vital service in a world of countless coin types. They assessed purity, took a small fee, provided the local currency a merchant needed. And then the porticos, those long covered walkways with columns. They provided shade, shelter from rain, but more importantly, they created a semi-private space for negotiation. A merchant could discuss a major deal away from the bustle, yet still in the public eye. It was architecture facilitating business. Within these spaces, guilds played a crucial role. Associations of potters, bakers, silversmiths. They weren't just social clubs. They set quality standards for their members' goods. They sometimes fixed prices to prevent destructive undercutting. They trained apprentices, ensuring skills were passed down. A guild seal on a piece of cloth was a mark of trust, a primitive form of consumer protection, embedded in the marketplace itself. A perfect case study is Rome's Forum, the ancient cattle market. It wasn't a random field by the river. It was a formal, organized space, located near the Tiber port for easy movement of animals. It had its own temple, like the Temple of Hercules Victor, invoking divine protection for the commerce there. It had dedicated infrastructure, water troughs, holding pens, slaughtering facilities, and again, those porticos for the dealers. It was a single-purpose commercial node, fully engineered into the urban fabric. So a modern shopping mall continues this. Think about its design. The central atrium is the main square. Anchor stores and food courts are the different sectors. The wide, climate-controlled walkways are the modern porticos. Security cameras are the market officials, and the online marketplace is the ultimate evolution. A digital Agora. User reviews are the new guild seal. Standardized digital payments are the money changer. Algorithms manage the flow of millions of transactions a day. The engineering goal remains identical: to facilitate exchange, build trust, move value at scale. But this vibrant energy came at a cost. Those bustling markets generated mountains of waste, from the slaughterhouses, the fishmongers, the spoiled produce, and they required a constant, colossal input: the grain, the animals, the raw materials. This highlights the city's true nature. It was a metabolic organism. It consumed, it processed, it excreted. The marketplace was the stomach, and the efficiency of that stomach depended entirely on the veins and arteries, the roads that brought the goods in, the warehouses that stored them, the sewers that carried the waste away. This commercial brilliance wasn't. It was the glittering output of a deeper system. A system of accounting so advanced it managed an empire's wealth without a single sheet of paper. Rome needed 6,000 tons of grain every single day. That grain came from Egypt, from North Africa, from Sicily. A huge area of land, all of it to feed the city. The city was like a living thing. It took in resources, food, water, wood, metal, and it pushed out waste, sewage, ash, garbage. The real engineering wasn't just the aqueduct. It was the entire flow. The system that got grain from the Nile to a loaf of bread in Rome. To feed 1 million people, the empire needed land far beyond the city. They figure it took an area the size of Tunisia, all that wheat, olives, wine for the capital. The grain ships were like arteries, carrying calories across the sea. But grain was just one thing. There was timber. Rome needed wood for building, for heating the baths, for making concrete. Forests were cleared for miles. Just one bath complex over years could use whole forests. Then there was stone. Mountains were for marble. Ore from mines was smelted for tools, for coins. Every resource was a line on a map, a line from a province to the Forum. And for everything that came in, something went out. The waste from 1 million people went into the Tiber. It fertilized some land, but it polluted the water. The ash from all those fires had to go somewhere. The garbage, broken pots, food scraps, old cloth piled up outside the gates. This was the waste of the urban body. Some places closed the loop. In China, they collected night soil. Human waste was gathered from cities, treated, taken back to farmland. It was a resource. It put nutrients back in the soil. Food from the country fed the city. The city's waste then fed the soil, which grew more food, a cycle. Other loops weren't so circular. Deforestation led to soil erosion. Hillsides washed into rivers, silting up harbors. Mining for lead and silver left scars on the land and hurt the people who worked there. The city's hunger changed the environment for hundreds of miles. So you look at our cities now. Does any modern city have a circular system? We still take water from far away. We still ship food across the world. Our waste gets buried or burned. We don't return it. Our system take, make, throw away. It's the same ancient problem, just bigger. The old solution, like the night soil cycle, feels like a forgotten lesson. Seeing the whole flow, the huge intake, the managed output, makes it all more impressive. It was a balance on a huge scale done with pre-industrial tools, and it makes you wonder, who was figuring all this out? Who had the plan for the whole organism? The answer isn't one engineer, it's a forgotten group of planners, the real minds behind the megacity. Of Miletus looked at that coastline and saw a grid, a perfect layout of streets, all right angles. That was Piraeus, the port for Athens. And he's often called the first real city planner. He wasn't just building things, he was designing a system for how people live, and that points to something. These ancient cities weren't accidents. They came from specific minds, a whole class of planners and engineers. Most of their names are gone, but their work is still there. The architect, though, was more than that. Vitruvius wrote about it. In his work, he said an architect needed to know drafting, geometry, history, philosophy, even music, because proportion and harmony weren't just about looks. They were principles for a stable building, and so a stable society. These men were synthesizers. They had to take a ruler's idea and turn it into stone, managing budgets, labor, the limits of physics. On the ground, their key partner was the surveyor. His main tool was a simple device, a staff with a crosspiece, plumb lines hanging from each arm. By sighting across those lines, he could mark perfectly straight roads over long distances. He stamped geometry onto the earth. Before any foundation was dug, his lines set the direction of every street, the edge of every square, the path of every aqueduct. His work was the invisible skeleton. The city was built on top of it. Then you had the officials, the aediles in Rome, magistrates in Greek cities. They oversaw public works, markets, building codes. They were the bureaucracy. They allocated funds from the treasury, organized labor drafts, enforced the rules that kept buildings from falling into the street. Their scrolls and tablets were the software, running the hardware of the city. So how did you learn this? Formal schools were rare. It was apprenticeship. A young man would follow a master builder. Start by mixing mortar, carrying tools. Over years, he'd learn to set a level, calculate a load, draft a plan. Guilds, like the Collegia in Rome, protected these secrets, made sure standards lasted. Technical knowledge was also in manuscripts. Vitruvius's work is what survived. It's a practical handbook, choosing building sites, constructing siege engines, theater acoustics. It shows the mind of a professional, solving problems with what he had. Think about the engineers in Constantinople. They had water shortages, the threat of siege. They built a hidden world underneath, vast cisterns like the Basilica cistern, supported by forests of old columns. These were hydrological batteries, storing rainwater and aqueduct flow to last through a drought or an attack. We don't know their names, but their solution, this massive, cathedral-like space built purely for function, shows a blend of engineering and foresight. Or earlier, Imhotep in Egypt, vizier to Pharaoh, he's credited with the step pyramid at Saqqara, the first colossal stone building. Historians note he was later, a rare honor for someone not royal. That tells you something. Mastering that scale, organizing thousands of workers for a monumental vision, was seen as a power almost divine. It was bringing order from chaos. So who are the master planners for a modern city? You might name a famous architect, a transportation commissioner, but it's more diffuse now. The vision is split among thousands of specialists: civil engineers, zoning boards, environmental consultants, data analysts. Their tools are computer models, geographic systems, but their fundamental challenge is the same. to impose a logic of flow, of stability, of communal life onto the chaos of a million human stories. We rarely celebrate them until something fails, but their plans, like the ancient ones, face the same tests: the slow pressure of time and the sudden shattering arrival of disaster. The city's real test was when its systems broke, when the aqueduct cracked or fire jumped a street or the ground shook. That was the 12th marvel, not building for perfection but engineering for recovery. Ancient capitals were designed with a hard-won understanding of disaster. They had to be. A single night could undo a century of work. So resilience was woven into the blueprint. In the materials, in the redundancy, in the shape of the streets themselves. It was the city's immune system. Disaster archaeologists look at the scars. In Antioch, a city shattered by earthquakes again and again. The evidence is in the layers. They didn't just rebuild the same way, they learned. Foundations got wider, mortar recipes changed. They started using more flexible timber frames inside stone walls. They adapted the blueprint itself based on brutal experience. In Rome, after the Great Fire, Nero's new building codes mandated fire breaks, wider streets, and they encouraged more brick and stone over wood. Catastrophe forced an upgrade in the city's physical code. Material choice was the first line of defense. It was a constant calculation. Wood was plentiful and fast, but it burned. Stone was strong against quakes and flame, but slow and costly. So many cities used a hybrid, a stone foundation that could sway, topped with a lighter timber frame, or like in Roman apartment blocks, a brick facade with a wooden interior. The goal was to balance risk and resources, to build densely but with materials that gave people time to escape. Redundancy was the silent guardian. Rome didn't have one aqueduct, it had 11. If an enemy cut one or an earthquake toppled a section, others kept flowing. Constantinople had its massive underground cisterns, months of water hidden beneath the streets safe from siege. Grain was stored in multiple warehouses across the city, not in one central silo. This distributed logic meant no single point of failure could collapse the system. The city could lose a part and keep living. The urban form itself could be adapted for survival. In Mohenjo-Daro, the entire city was built on massive, man-made platforms, raised above the floodplain of the Indus River. This wasn't just for prestige. It was a permanent solution to seasonal flooding. In the Aztec capital built on a lake they engineered, these floating gardens were more than farms. They were anchored plots of fertile land, woven from reeds and mud. Their buoyant, rooted nature made them resilient to the soft, shifting lakebed. This was agriculture designed for instability. Then there were the organized responses, the Roman vigils, 7,000 men divided into cohorts. They were more than night watchmen. They were Rome's fire brigade, equipped with buckets, pumps, hooks to pull down burning buildings. They patrolled the dense districts, their presence a deterrent. They had the authority to commandeer private water to fight a fire. This was an emergency service funded by the state for urban preservation. For food security, the emergency grain reserve was a buffer against panic. When the Nile flood failed or storms wrecked the grain fleet, the state could open these reserves, selling grain at a fixed price or distributing it to prevent riots. It was a shock absorber for the social order, a literal stockpile of stability. Engineering for flood control was a constant battle. Rome built embankments along the Tiber. The Cloaca Maxima, that great sewer, was originally a channel to drain the marshy valley. They didn't just fight the water, they gave it a designated path. In ancient China, systems of canals and dikes were maintained by conscripted labor, a communal duty to manage the river's power. All this asks a question. What makes a city anti-fragile? Not just strong, but able to benefit from shocks. The ancient answer wasn't just stronger walls. It was about diverse responses, flexible materials, backup systems, and critically a population integrated enough to work together when everything fell apart. Resilience depended on that social cohesion. On the baker sharing his oven, the neighbor helping clear rubble, the migrant bringing knowledge from a land that built for earthquakes. That integrated diversity was the final unbreakable layer. The layer that decided whether a city would be a ruin or a story of rebirth. Alexandria. The air there, papyrus and salt. Greek philosophers walking next to Egyptian priests, Jewish merchants, all on the same streets. But at night they'd go back to their own quarters. That was the 13th wonder, not a lighthouse or a garden. a wonder of people. A capital city at that scale, it had to be a melting pot. It pulled in everyone from everywhere. The real task was making them live together, keeping all that diversity from breaking into pieces, into conflict. The solution was a kind of social engineering, subtle, fragile, a mix of policy and city design and a calculated tolerance. It started with the layout. Many old capitals did this. District planning, not always from prejudice, sometimes just for management. Alexandria was divided. The Greek, the Egyptian, the Jewish quarter, each with its own leader, its own temples, its own ways. That allowed a self-governance. It let a community keep its identity inside the huge machine of the city. You manage complexity by making smaller units inside the metropolis. Policy could encourage that separation, or it could build bridges. The Persian Empire under Cyrus, they had a policy of respect. Conquered people kept their local laws, their gods, their languages, as long as they paid tribute, as long as they acknowledged the Persian king. That was integration through layered loyalty. You could be a Jew in Babylon, a Greek in Ionia, and still a subject of the King of Kings. It lowered the friction. It turned possible rebels into taxpayers. But segregation alone, it can't run a city. Interaction was needed for the economy to work. So they built common spaces where different groups had to meet. The marketplace was the ultimate mixer. In the Agora of Athens, the Forum of Rome, a deal needed a common language, even if it was just gestures and numbers. A Babylonian trader and a Phoenician sailor had to agree on a price for tin. The public baths did something similar. In the steam of a Roman, social barriers might soften for a little while. The shared experience of the city, the games at the circus, the grain distribution, that created a common calendar, a shared rhythm of life across neighborhood lines. The law code was the foundation. Hammurabi's stele had laws for all. Roman law developed the gentium, the law of nations, rules for commerce between people of different origins, a legal framework for diversity. It said no matter your birth, a contract is a contract. A debt is a debt. That gave a predictable, neutral ground for disputes. A merchant from Carthage could sue a Roman citizen in a Roman court and expect a ruling based on procedure, not just on who he was. Policing this mosaic, it was a constant, delicate task. Authorities walked a fine line. They might allow a festival for a foreign god but watch the crowd for trouble, permit a synagogue or a temple of Isis to be built but monitor its gatherings. Major riots like the ones in Alexandria between Greeks and Jews that showed the system breaking. The state's response was usually overwhelming force to restore order, then commissions, negotiations. Keeping the peace was an active, daily engineering problem. They built cultural infrastructure for this plurality. The Great Library of Alexandria itself was an engine of integration. It tried to collect all the world's knowledge, Greek, Egyptian, Persian, a shared intellectual project. Cities often had multiple major temples. In Rome, the Temple of Jupiter on the hill and the Temple of Isis and Serapis across the city. That architectural acknowledgement sent a message. Your God has a place here, so you have a place here. The most powerful tool was citizenship. The Roman policy of gradually granting it to allies, to freed slaves, eventually to almost all free people in the empire, that was a revolutionary social technology. It was a pathway. It said no matter where you were born, you could become Roman, marry a Roman, own land under Roman law, serve in the legions, hold office. That turned conquered people into stakeholders. It channeled ambition and talent into supporting the system, not overthrowing it. The integration was so complete that by the empire's height, many emperors came from provincial, non-Italian backgrounds. So you look at modern global cities, Chinatown, Little Italy, the Kurdish district, they serve that ancient purpose, a familiar harbor in a vast metropolis. Our laws against discrimination try to be the new gentium. Our public schools, our libraries, they're the common ground. The question is still the same. How do you build a shared civic identity strong enough to hold while letting individual cultural identities flourish? The ancient answer was never perfect. It involved zones of separation and arenas of forced mixing. It relied on a central power enforcing a minimal set of rules for everyone, but at its best it created something. A city where the tapestry of humanity wasn't just present, it was the source of its strength, its innovation. This integrated energy, this controlled chaos of different minds and traditions, it fed the city's most visible output, its beauty, its art. That stunning aesthetic grandeur. That was the final, deliberate message to the world. The marble was white, but it wasn't just a material, it was a weapon of light. You'd approach the city gates and the sun would hit those polished surfaces. It created a blinding corona, a halo around the silhouette of power. That was the final layer, a conscious engineering, the aesthetics of control. Every capital was engineered to function, yes, but also to overwhelm, to communicate a message: stability. Divine favor, absolute authority, all before a single word was spoken. The principle was a single dominant line. A processional road, dead straight, it led the eye, it led the body. Inexorably toward the seat of power, you didn't wander into the presence of a king. You were marched there by the architecture itself. And symmetry reinforced it, perfect balance on either side of that central axis. It spoke of order, a world in perfect managed equilibrium. And at the end of that axis, the vista, a framed view, a palace facade, a temple pediment. A colossal statue. The city was a sequence of reveals, each one building on the last to maximize awe. Art historians point to the materials. In the Athenian Acropolis, the Parthenon, built from brilliant white Pentelic marble, but it wasn't left plain, it was painted. Vivid blues, reds, golds, the sculptures were detailed, lifelike, gilded to catch the fire of the sun. This wasn't subtle, it was a dazzling spectacle, a calculated display of wealth, of technical mastery, meant to be seen from the city below. In Rome, the travertine, the marble, often looted from conquered nations. That was a political statement, in stone. The message was clear: we command the resources of the world. This visual engineering extended to spaces. The sequencing of spaces. Think of the Forbidden City in Beijing. You didn't just walk into the throne room, you passed through gates, massive gates. You crossed courtyards, vast courtyards, you ascended stairways. Each threshold was a transition, a psychological preparation. The spaces grew more exclusive, more ornate, more silent. By the time you reached the inner sanctum, the architecture had humbled you. It had narrated a story. A story of ascending hierarchy, with you at the bottom and the solitary emperor at the pinnacle. Water and greenery were tools, not afterthoughts, reflecting pools placed before monuments. Like the long canal leading to the Taj Mahal, it doubled the grandeur. The still water created a mirror image, amplifying the size, the symmetry, making it appear to float between heaven and earth. Gardens in Persian palaces, laid out in precise geometric patterns, divided by water channels, they represented paradise brought to earth, a testament to the ruler's ability to tame nature into an ordered, beautiful submission. A perfect case is Persepolis, the processional way. Visitors from across the empire would climb the grand stairway. The steps were shallow, wide, so dignitaries could ascend on horseback, in procession, without breaking stride. They would pass through the gate of all nations, flanked by colossal stone bulls, then walk the long avenue lined with endless reliefs, showing representatives of every subject nation. Bringing tribute, the imagery was unambiguous. You are part of a vast, orderly empire. And your role is to bring wealth to its glorious, immovable center. The entire approach was a slow build-up, a cinematic build-up, to the great audience hall, where the king, elevated and framed, would receive them. So look at the landmarks in your own city. The long, wide boulevard leading to a Capitol building, the imposing staircase of a museum, of a courthouse, the soaring glass-faced skyscraper dominating the skyline. These are not accidents of design, they are modern applications of the same ancient principles engineered for visual impact. What message do they send? Order, transparency, prosperity, corporate power. The language of stone and space is still being spoken. But this grandeur, this perfect stone facade, it had a hidden vulnerability. It was not set and forgot. It demanded a relentless effort, an unseen effort. The gleaming marble had to be scrubbed, the gilding had to be replaced, the gardens had to be tended. The city's magnificent face required constant upkeep, a never-ending cycle of renewal. That few ever saw. The curator walked the stone channel looking for cracks. He carried a bronze scraper to clear the silt that could slow the water. This wasn't a ceremony, it was a routine inspection. And it was the main reason the aqueduct worked for 500 years. The real engineering marvel was the least visible. It was the regime of maintenance, a funded bureaucratic system designed for one purpose: to fight the slow decay of everything. Because a city isn't a monument you build once, it's a living system you have to repair every day. This was the hidden layer of governance. the unglamorous work that kept the urban machine from grinding to a halt. In Rome, entire government departments existed for this. The curators oversaw the roads. The curators managed the aqueducts. These weren't volunteers. They were salaried officials with staffs of engineers and laborers. Their budgets came from the state treasury, from specific taxes on trade or property. This was a formal commitment to upkeep. It acknowledged a truth. The greatest engineering is useless if you don't maintain it. The tasks were endless and meticulously recorded, repaving worn sections of the via, dredging silt from the Cloaca Maxima before the autumn rains, replacing rotten beams in the theater of Pompey, scrubbing algae from public fountains, whitewashing the walls of apartment blocks, even cleaning statues in the Forum from soot and bird droppings. This was the city's metabolism, the constant cellular repair that kept the organism healthy. Financing this was its own challenge. States used a mix of methods. Direct taxation was common. A portion of the grain tax in Egypt went to maintaining the canals that grew the grain. Labor was another tool, a requirement that every citizen provide days of labor per year for public works. This mobilized massive workforces for clearing ditches or repairing walls. Wealthy individuals often took on maintenance as public patronage. A senator might pay to resurface a road in his home district. Earning prestige while fulfilling a duty. This blend of state funding, compulsory service, and elite philanthropy created a safety net. We have detailed evidence of this from much earlier. In the Ur-III period of Mesopotamia, around 2100 BC, scribes kept clay tablets that are maintenance logs. They record the number of laborers assigned to clear a specific canal, the amount of earth they removed, the rations of barley they were paid. They note the delivery of bitumen to waterproof a temple foundation. These aren't grand royal annals. They're the work orders of a functioning bureaucracy, proving that systematic recorded upkeep is as old as cities themselves. The true test came as empires aged. As tax revenues fell or central authority weakened, the maintenance regimes were the first thing to suffer. A crack in an aqueduct went unrepaired. A section of sewer clogged. A road's surface eroded into a rutted track. The decline was rarely a dramatic explosion. It was a slow leak, a cumulative failure of these small, daily acts of repair. The city didn't fall in a day. It unraveled stitch by stitch as the threads of maintenance were dropped. This forces a question about our own world. We celebrate ribbon cuttings for new bridges, new subway lines, new airports. But do we celebrate the inspectors who check for corrosion, the crews who replace worn rails, the engineers who monitor the slow settling of a dam? Is our modern infrastructure suffering from the same ancient peril? A focus on the grand gesture over the grinding work of preservation. We've replaced the curator with sensor networks and digital dashboards. But the principle is unchanged. Sustainability isn't about what you build. It's about what you're willing to sustain, year after year, century after century. The ultimate proof of this upkeep wasn't stasis. It was the city's quiet, continuous evolution. A repaired sewer line might be rerouted. A rebuilt market might incorporate new materials. Maintenance was never just about putting things back the way they were. It was an ongoing conversation with the city itself, a dialogue of adaptation. And this constant low-level adaptation prepared the urban fabric for its most profound transformation, not from where, but from a radical shift in the very idea that ordered it all. A new vision of the world rising from within the old stones. The original walls ended up like a belt around the city's middle, and then the city grew a new body around that belt. Rome's Servian wall was built for a smaller republic, and it was soon just engulfed. The city spilled over the Tiber into the Trans, it crawled up the hills. That was the 15th marvel, not just building a city but letting it grow, engineering for expansion, a plan that could stretch, because a capital that couldn't grow was a capital that would die. The challenge was scaling the original blueprint without breaking it. How do you extend order into chaos? Make a suburb feel like part of the city's heart. Urban morphologists see two forces: organic growth, the messy practical sprawl of people building where they need to, and planned expansion, the state trying to impose its grid, its logic onto that new territory. The history of ancient megacities is the history of that tension. A farmer's path becomes a lane. That lane gets paved. It becomes a secondary street. Eventually, it might be straightened, widened by a surveyor's team, incorporated into the grand design. The first tool for expansion was the street grid itself. In cities built from scratch like Roman colonial towns, the grid was designed to be extendable, like a checkerboard that could keep adding squares. When population pressure mounted, the main cross streets, the Encardo, were just projected outward. New blocks were surveyed, plots were sold or granted. The geometric logic replicated itself. In older cities like Athens, expansion was less tidy. The Piraeus port was linked to the city by the long walls, a fortified corridor. Growth happened along that protected spine, then filled in the spaces between. But streets are just the skeleton. The real test was extending the life support systems. The aqueduct that ended at the old city gate now had to be extended. New branches were tapped off the main line. Siphons were built to carry water across valleys to reach new hillside neighborhoods. The sewer network had to be expanded. New trunk lines were dug, connecting to the main outflow. That was infrastructure thinking at its most ambitious, not just maintaining but projecting the system forward into space. Often expansion meant swallowing whole other towns. Rome didn't just grow into empty land. It annexed neighboring settlements, on the surrounding hills. The engineering task then was integration. Their local springs might be connected to the greater aqueduct network. Their dirt tracks were upgraded, aligned to meet the Roman road grid. Their forums might become local market squares within the greater metropolis. That was a political and technical process. It required land acquisition, compensation, a massive coordination of labor to tie the new piece into the old system. In phased growth is Constantinople. Its defensive walls were rebuilt 3 major times, each set further out. The original wall was soon. Then came the massive walls in the 5th century, enclosing a huge new area of fields, monasteries, palaces. This wasn't just moving a fence. It was a colossal act of preemptive planning. They built the new walls through open countryside, anticipating the city's growth, and then the city filled in the space behind them. Each new wall required a complete re-engineering of the military perimeter. New gates, new towers, new moats. And inside, the civic infrastructure, water cisterns, major avenues, forums, had to be extended to service this new, larger urban canvas. The political hurdles were immense. Expansion meant displacing people. It meant claiming farmland, negotiating with powerful landowners, using eminent domain centuries before the term existed. It required a central authority with the will and the wealth to see it through. The funding had to be secured, often from conquest or heavy taxation. The expansion of a capital was the ultimate display of state power. Control not just over people but over geography itself. So that question returns. Can a city's original operating system handle unlimited growth? The ancient evidence suggests not without major upgrades. The simple grid of a small colony might work for a time. But to scale to 1 million, you need the aqueduct extension, the second sewer trunk, the new granary complex on the outskirts, the fresh set of walls. You need to reboot the infrastructure, if not the entire social code. The city that stopped expanding its systems, that tried to cram endless growth into an adolescent framework, faced congestion, pollution, collapse. This expansion was ultimately fueled by a quiet, constant force, the spread of knowledge. A technique perfected in Rome for making waterproof concrete would appear in provincial capitals. A Persian design for a Qanat would be adopted in arid regions far from Persia. Engineering principles themselves were the most valuable export. They were the software that allowed new hardware to be built and old cities to grow. That diffusion of ideas was the silent engine behind every new wall, every extended aqueduct. It connected the fate of one sprawling capital to the innovations of another, across continents and centuries. A Roman engineer would have seen that arch in a Mesopotamian ruin and known it. That shape, the way it holds weight, it was a shared secret. The real foundation for these cities wasn't stone. It wasn't water. It was knowledge moving. A toolkit that traveled with armies on ships in the minds of captured artisans. The spread of these engineering ideas created a shared language. It meant a planner in Gaul didn't have to invent the sewer again. He could adapt the Cloaca Maxima. A builder in Syria didn't have to solve the arch from nothing. He could refine what the Etruscans had already done. This cross-pollination turned local ideas into global standards. It was the network effect of the ancient world. Conquest was the most brutal vector, but it was effective. When Rome took the Hellenistic kingdoms, they didn't just take land. They took libraries of technical knowledge, Greek writings on geometry, on mechanics, on water systems. Roman engineers studied them, translated them, then applied that learning on a huge scale. The arch, probably developed earlier in Mesopotamia, was embraced by Rome, They combined it with their own material, concrete, to build structures of amazing span. The Pantheon's dome is the result of that fusion. A Greek geometric ideal built with Roman concrete, a space that felt like the vault of heaven. Trade routes carried blueprints. The Silk Road moved more than goods. Ideas moved. Caravan stops, places like Samarkand, became hubs for exchange. A Persian engineer might explain the Qanat, an underground channel, to a Chinese official facing drought. A city planner in Central Asia might adopt a Greek grid layout but adapt it to local materials. The city of in what's now Afghanistan shows this. A perfect Greek grid plan with a gymnasium and theater built far from Greece. But it was built from local, it used regional motifs. It was a hybrid, a blueprint transplanted then adapted to new soil. Diplomatic missions were another channel. An embassy didn't just bring gifts, it brought observations. Scribes and architects in the group would note street width, harbor designs, water systems. Their reports went home. They informed their own rulers' ambitions. Chinese urban planning with its north-south axis and walled enclosures influenced ancient Japanese capitals like, that's modern Nara. It was a conscious import, an entire philosophy of ordered space. But the most vital vector was the artisan, the skilled worker who carried knowledge in his hands. When a kingdom was conquered, its best builders, its metalworkers, its water engineers were taken as spoils, relocated to the victor's capital. There they worked alongside local craftsmen. Techniques were shared, blended, improved. The movement of these people, sometimes forced, sometimes seeking patronage, meant a solution from the Persian deserts could find new life in Roman North Africa. The toolkit grew with every journey. This shared pool meant some tools became universal. That the Roman surveyor's cross had ancestors in Egypt and Mesopotamia. That the water level for aqueducts was a refined version of earlier tools. Standard plans for barracks, granaries, basilicas circulated through empires. An engineer on the frontier in Britain could build a bathhouse functionally identical to one in Rome, using local stone but following an imperial template. That reproducibility was a force multiplier. It allowed rapid, reliable construction across thousands of miles. But adoption was never a simple copy. Local context dictated the final form. The Roman hypocaust, that underfloor heating for baths, needed lots of fuel. In the forested north of Europe, it was widely used. In the drier, treeless provinces of North Africa, it was rare. There, builders focused on passive cooling, thick walls, shaded courtyards, ventilation. They took the principle of climate control from the Roman toolkit, but solved it with different tools. Similarly, the arch, so fundamental to Rome, was built in wood in China for centuries before stone. Adapted to a different material tradition, a different seismic reality. It makes you think about our own time. We have instant global communication. A skyscraper design in Dubai can influence Shanghai in hours. Our digital networks have accelerated the diffusion of knowledge to light speed. But has the fundamental process changed? We still see the same pattern. A revolutionary material like ultra-high-performance concrete spreads. A sustainable design principle like passive house standards is adopted and adapted to different climates. We still have a global toolkit. Now it's digital, hyperconnected. The challenge is the same as it was for the builder of, how do you take a foreign idea and root it in your own local soil, with its unique constraints, its materials, its needs? This accumulated cross-cultural wisdom was what planners drew on in a city's final phase, not during its expansion, but in its long negotiation with time, with scarcity, with a changing world. Knowing how to build a city was one thing. Knowing how to manage its transformation or its gentle closing act, that was the final chapter in the manual. The aqueduct's last flow didn't break. It just stopped, a slow silting up, a few stones gone, a leak nobody could afford to fix. That was the 16th wonder, the quiet one, not building for the peak but planning for the fade, managing the decline. A city's systems, engineered for growth, now had to face contraction. How do you run a retreat? How does a city built for 500,000 become a town of 50,000? That was the final engineering problem, a counterpoint to all the ambition. Archaeologists see a pattern in collapse. It's hardly ever one event, it's a chain. The tax base shrinks, so maintenance gets cut. A stretch of aqueduct is abandoned. That neighborhood uses wells now. Wells can go bad, public health slips. The workforce weakens. Fewer people to clear the sewers start to clog, flooding gets worse in the low areas, those neighborhoods empty out, the tax base shrinks again. It's a spiral, a slow unraveling of the systems that made the city. So people didn't just vanish. They made choices, they did triage. They consolidated the vital functions. Early medieval Rome didn't vanish, it shrank. Its huge population spread over 7 hills pulled back to the defensible bend in the Tiber. To the old campus, the Aurelian walls still stood, but they enclosed fields, ruins, orchards. The lived-in city was a small kernel inside the giant fossil of what it had been. That was a planned retreat. Giving up the outer edges to keep the core alive. The engineering challenge flipped. How do you maintain a sewer system for 1 million with 100,000 people? The answer was cannibalization. The great monuments became quarries. The marble from the Colosseum was stripped for lime. The lead pipes from the aqueducts were melted down. The stones from forgotten temples were hauled off to build smaller churches, fortified houses, city walls. This wasn't vandalism. It was recycling, pragmatic. The old infrastructure was repurposed for new needs. The city consumed its own skeleton to survive. Ports were a special problem. A harbor silts up from river mud. It becomes useless for big ships. Instead of a massive dredging project, the whole economic center might shift. Ephesus is the example. Its great harbor, the source of its wealth, slowly filled with silt from the river. The sea retreated. The city's commercial life faded. The people gradually moved to a new settlement down the coast where the water was still deep. The city didn't die. Its heart relocated. It left its old body, the library, the theater inland, a monument to a lost coastline. Sometimes the monumental core itself was reused with pure practicality. The Roman Forum, the center of the world, became a pasture. Campo, the cow field. The great basilicas, roofless, were turned into fortified strongholds for powerful families. The Arch of Titus was built into a medieval fortress wall. The sacred spaces of the old city were stripped of their meaning and folded into the gritty reality of a smaller town. That was adaptive reuse, on a colossal, unconscious scale. It raises a hard question now. We design our cities for growth. Our zoning, our infrastructure plans, our politics all point to more. But what's the plan for less? Should a modern city facing a shrinking population from economic change or climate have a blueprint for managed decline, not as a failure, as a deliberate strategy? To consolidate neighborhoods on purpose, to decommission water lines in emptying areas before they decay and poison the groundwater, to turn abandoned tracts into green space, stormwater buffers, urban forests. The ancient evidence says unmanaged decline is chaotic and wasteful. Managed contraction, as hard as it is, might be the ultimate act of long-term stewardship. But the legacy of these cities lasted. Their stones were reused, but their ideas weren't buried. The grid of a Roman town often lives under a modern street plan. The path of an aqueduct might become a country road. The memory of that scale, that ambition, lingered in stories, in laws, in the shape of the land. The city as a physical thing might shrink, but as a blueprint for how people lived together, it had already escaped. It was out in the world, waiting to be found again, reinterpreted. Reborn in a new time with new tools. The last chapter of the ancient megacity wasn't an ending. It was a transmission. There's a planner in Tehran looking at an inn, a passive cooling tower 1,000 years old. She's not studying history. She's reading a blueprint for a carbon-neutral future. The legacy of those ancient cities isn't locked in ruins. It's alive in our streets. We're living in the echo of their engineering. The line from a Roman aqueduct to a gravity-fed water system is clear. But the deeper influence is in the principles. They're solutions to density, to waste, to social cohesion. We're rediscovering them now, not as curiosities, as urgent innovations. Take mixed-use zoning. Modern urbanists talk about blending housing, shops, workplaces. It cuts commutes, creates walkable streets. That's not a new idea. It was the default in the ancient city. The Roman Insula had shops below, apartments above. The Athenian Agora mixed law courts, temples, market stalls. They engineered for proximity because they had to. The city's survival depended on it. And now, after a century of rigid separation, we're relearning that. The goal is the same. To build a city where daily life doesn't require constant, energy-intensive movement. Green corridors are another echo. The shaded porticos of Roman markets. Sacred groves, temple gardens, they were urban oases. Today's planners design greenways along old rail lines, riverbanks, engineering natural pathways for recreation, for wildlife, for stormwater. It's the same principle, weaving nature into the urban fabric. not as an afterthought, as a vital organ. Then there's decentralized infrastructure. The ancient city had multiple water sources, aqueducts, cisterns, wells. If one failed, others took the load. Our grids are centralized. One power plant goes down, a region goes dark. One water main bursts, a neighborhood is without water. Now the push for microgrids, for distributed solar, for neighborhood-scale water recycling. It mirrors that ancient wisdom. It's a return to redundancy, building a city that can lose a piece and keep functioning. Studied how people actually use public space. His work in Copenhagen drew from the human scale of medieval plazas, but those plazas were heirs to the Roman Forum. The principle is timeless. Design the space, and the life will follow. When we build a pedestrian square today, we're in a conversation that started with the first planner who left an open area at the city's heart. The challenges are similar. How do you move people without gridlock? Roman traffic management with main arteries and restricted cart traffic finds its echo in congestion pricing and pedestrian zones. How do you conserve water in an arid climate? The in Petra engineered channels, dams, cisterns to capture every drop of rainwater. Researchers now study those systems for insights in the American Southwest, the Middle East. This has given rise to ancient urban metabolism, looking at the city as a living organism that consumes resources, produces waste. The goal is a circular economy, where waste becomes input. The ancient practice of using night soil as fertilizer is a humble example. Today the ambition is grander, closing the loop on water, energy, materials, turning a linear system of take-make waste into a circle, just as some ancient societies did out of necessity. Passive design is a powerful illustration. Before air conditioning, cities in hot climates were engineered to stay cool. In India, planning used water channels, shaded courtyards, vegetation to create microclimates. The of Persia funneled cool breezes underground. Architects now integrate these techniques into sustainable designs, proving the most advanced solution might be one that requires no electricity at all. So are we in a new golden age of urban engineering? The tools are dazzling, smart sensors, autonomous vehicles, but much innovation just optimizes the old, broken model. The real revolution might be philosophical, a return to first principles, asking the ancient planners' question. If you had to build a city for 1 million people with a focus on harmony and permanence, where would you start? You might start by looking at the cities that did it, that lasted 1,000 years. Their legacy isn't just in the stones we reuse. It's in the questions we've finally remembered to ask. How do we build a city that belongs to its people, that works with its environment, that can endure? In seeking those answers, we're not just moving forward, we're closing a circle, reconnecting with a deep lineage of problem-solving. The ancient engineers' greatest marvel may be this, that their work, silent for centuries, is now speaking to our most pressing crisis, an offering, not a relic. A way forward, a city of 1 million people that wasn't an accident, it was a choice, and that choice was built. It was built in 16 systems of stone and water and law and belief. We've seen the gentle slope of an aqueduct, we've followed the path of a sewer, we've stood on a sacred axis in that engineered silence. Each one solved a problem of scale. But the genius wasn't in any one marvel, it was in how they connected. The grain supply let you have a standing army. That army secured the roads fed the markets paid the taxes, and the taxes funded the aqueduct. It was one machine, a single vast machine. A conscious work of art built to function, that's the key, this profound integration. These cities didn't grow and then add systems later. The systems were the city, the grid came first, then the wall, then the pipes, the channels, the things that gave it life. Resilience was woven in, through redundancy, multiple aqueducts. Distributed granaries, layered defenses, and they were adaptive. They learned from disaster. They incorporated ideas from across empire. They expanded and they contracted with a kind of grim practicality. They thought in centuries, not in election cycles. Their planning acknowledged a simple truth, a brutal truth. A city is only as strong as its weakest essential system. So what does that mean? For the cracked pavement outside your window, for the traffic jam on your commute, for the water from your tap. The relevance isn't metaphorical, it's direct. Our modern urban crises, they're echoes of ancient puzzles: housing density, waste management, public health, social cohesion, sustainable resource loops. These aren't new problems, they're the eternal problem, the problems of people living together at scale. The ancient solutions offer a different way of seeing, not a list of disconnected issues, but a single interconnected web. You can't solve traffic without considering housing. You can't ensure public health without managing waste. You can't have social stability without food security. They engineered for the whole organism. And that points to a forgotten priority, the ethics of maintenance. We celebrate the new bridge, the shiny tower. But the ancient world celebrated the curator, the official who kept the water flowing. Their greatness was measured not just in what they built, but in what they sustained. A city's legacy is written in its repaired stones, its clean channels, its repaved roads. The most sustainable city isn't the one with the most dazzling new technology, it's the one with the most dedicated caretakers, the one that invests as much in upkeep as in innovation. The historian Lewis, he called the city a fact in nature, but also a conscious work of art. That duality is everything. It's a physical metabolic fact, consuming, excreting, requiring energy. And it's an artistic social vision, a place of meaning and belonging and shared identity. The ancient engineers never separated the two. The aqueduct was a hydraulic miracle and a monument to civic order. The temple was a spiritual axis and a feat of gravitational defiance. They built for human dignity and practical necessity in the same breath. Let this change how you see the place you live. Look down. The manhole cover is a portal to a Cloaca Maxima. The wide boulevard is a descendant of a Roman. The public park is an echo of a sacred grove. The zoning code is a child of Hammurabi's steel. The hidden engineering is all around you, in the pipes and the wires and the rights of way that hold your community together. Now turn that into a question. Look at a challenge in your own city. The flooding street, the unaffordable neighborhood, the lonely public square. What ancient principle whispers a solution? Is it the circular economy of night soil? The multifunctional space of the forum, the distributed redundancy of the water network? The answer is likely already here, waiting in the stones of the past. Share what you see. The conversation about our urban future needs every perspective. If you've enjoyed this journey into the engineered heart of ancient mysteries, there are more wonders